One of the first places that we see an advantage to radian measure over degree is using the very definition of radian. Since radian is just a measure of the part of the circumference that's traversed, and remember we're talking about the unit circle. So if that radian measure helps us determine what part of the circle was traversed, then we can use that to calculate something called arc length. And the arc length is what portion of the circumference we've traveled. Arc length is defined as theta over 2 pi, so that radiant degree divided by 2 pi, times the circumference. Remember, this is circumference. And when we calculate that, notice the 2 pi's cancel. And so pi r is defined as our arc length. Notice that if we went the whole circle, that arc length would be theta over 2 pi times 2 pi r. But in that case, that theta would be 2 pi, which would cancel, and we would be back to the entire circumference of the circle. An example of where this might be used, consider if we were looking at the Earth, and if this is the equator, the Galapagos Islands fall at the 90-degree west longitude, and the international dateline falls at 180 degrees. If we want to see how a ship is traveling, if a ship travels between the Galapagos Islands and the international dateline, it's traveling along the equator, which is the outer edge of a circle if you look at a cross section of the Earth. That arc length we can use to help determine how far the ship travels, and that arc length is just going to be theta times the radius. Well, the theta between 90 degrees and 180 degrees is 90 degrees, which is pi over 2 radians. And you would need to know the radius of the Earth, which is 6,370 kilometers. When we multiply that, we can calculate that that ship would be traveling approximately 10,006 kilometers. Now, suppose that that ship took 15 days. We can calculate or turn this into a speed then. Remember, speed is just distance divided by time. So if the ship travels a distance of 10,006 kilometers in 15 days, but then if we want to change those days into hours, remember, there's 24 hours in one day. Again, that conversion factor, days will cancel. We end up with 27.8 kilometers per hour is how fast the ship would be traveling. The information on how things are moving around a circle is often given in how quickly that angle changes. And this is defined by something, a new definition we're going to use called angular speed. And that angular speed is represented by omega, the Greek letter omega, and it is defined by the change in the angle over time. This can then be related to linear speed, or that velocity that you're used to hearing is how far you travel along the edge of the circle, the distance you travel, the arc length divided by time. But we know that arc length is r over r times theta. Again, we're dividing by t, but we just defined this to be the angular speed. And so we can then calculate the velocity, linear velocity, to be the radius times the angular speed.